Okay, so the first thing we want to actually do is we want to figure out what the ride is doing. So we're going to sort of like the problems we just did, only this is backwards. So let's draw a picture of this, right? What are they telling us? At the bottom, okay, so 1g plus the ride is equal to 1.305 g's. Okay, well, doesn't that mean that the ride is 0.305? So the ride is equal to 0.305 g's, right? Because if you add that to 1, you get 1.305, right? So that is the first step. You notice we don't even ask us about the top. We could figure out what the top is, right? At the top, it would be 1g minus 0.305. 1 minus 0.305. I feel like I need to do that, 0.695. So you'd feel 0.695 g's at the top. A little more aggressive than our Ferris wheel, right? But we don't care about this. We don't care about this. This is what we care about, right? So the next step is turn it into meters per second squared. It's exactly the opposite, right? So to turn meters per second squared into g's, we divide it by 9.8. But to go from g's to meters per second squared, you just multiply by 9.8. So 0.305 9.8 is how much? Okay, so 0.305 times 9.8 is 2.989. Centripetal acceleration is 2.989 meters per second squared, right? So that's your second step. Your third step is find, in this case, the velocity. I think I'll ask you for the period if it's sometimes I'll ask you for the velocity, right? If it's velocity, use this guy, right? Centripetal acceleration is v squared over r. So 2.989 is equal to v squared divided by, what's our radius? Oh, 8.1 meters. There's the radius right there. Okay. So v squared is equal to 2.989 times 8.1. That's 24.2109. That's a 4, right? And then to get v, we're going to square root that, right? So I get 4.92. The velocity is 4.92 meters per second. All right. So again, for this thing, you have to figure out this whole circle thing first, the 1 plus or 1 minus. Once you know what the ride is doing, turn the ride into meters per second squared, and then use one of your formulas, right? You might also use 4 pi squared r over t squared if you're solving for t, right? But in this case, they asked you for the v, so we used this guy. And we didn't use this, okay?